a cinematic narration of a cosmic stage where stars blaze for billions of years, only to die in fire or silence. Yet in the infinity galaxy, a star vanished without a final scream of light. No supernova, no radiant explosion, only darkness remained, leaving astronomers to wonder, how can something so immense collapse in silence? The hook sets the tone of awe, dread, and cosmic mystery. Welcome. You are watching Whisper Science. Make sure to subscribe and join us for more amazing science content. Now, let's move back to the video. The universe is vast enough to hold a billion secrets, but sometimes it delivers one that leaves even the most seasoned astronomers speechless. In the summer of 2025, their gaze fell upon a galaxy that already seemed designed by the hand of mystery. It was called the Infinity Galaxy, a cosmic structure 8 billion light-years away, discovered in JWST's wide surveys. At first glance, it looked like two shining rings colliding in space. An almost perfect figure eight, a symbol humans have long associated with eternity. But within its luminous embrace, an event had occurred that seemed to tear through the very rules of astrophysics. A star that should have died in brilliance collapsed into darkness without a trace. This chapter is the story of how that discovery unfolded, from catalogs of ancient starlight, to the cutting edge of space telescopes, to the quiet realization that a star had disappeared without warning. The Infinity Galaxy was not unknown before JWST. Its image had already appeared faintly in Hubble's deep surveys and ground-based telescopes like Keck. Astronomers noticed its odd geometry. Twin luminous rings, remnants of a collision between two massive galaxies whose stellar disks were passing through one another like ghosts. The clash had triggered furious star formation. Thousands of suns were being born in the compressed gas lanes, lighting up the galaxy like sparks from colliding steel. But it was James Webb's near-infrared camera NIRCam that transformed this smudge of light into revelation. Webb's mirrors, 6.5 meters across, captured the Infinity Galaxy in unprecedented detail. Astronomers expected to find supermassive black holes at the centers of both colliding galaxies, glowing brightly as matter spiraled inward. They did, but they also found something else. In between the two rings, where there should have been nothing but turbulent gas, a third compact object emerged in Webb's spectrum. It shone faintly in infrared, betrayed only by the dust it heated. At first, many thought it was a background galaxy, a cosmic coincidence. But spectroscopic analysis showed it was locked to the same redshift as the Infinity Galaxy itself. It was real, and it belonged to this cosmic collision. The surprise was not merely its position, it was its nature. The light it emitted bore the unmistakable fingerprint of matter being consumed, the signature of a black hole. And yet, when astronomers compared the data to Hubble's archives, they realized something chilling. A luminous star had once existed there, recorded faintly decades earlier. Now it was gone. Stars are patient storytellers. For billions of years, they burned steadily, fusing hydrogen into helium, balancing the inward pull of gravity with the outward push of nuclear fire. But when they run out of fuel, their deaths are supposed to be spectacular. Massive stars die in supernova, explosions so powerful they outshine entire galaxies for weeks. These events scatter heavy elements into space, seeding planets and life itself. They are loud farewells, written in light and energy. But the star in the Infinity Galaxy had not followed the script. Hubble's record showed it shining steadily, catalogued in surveys as a bright point within the chaotic dust lanes. The Sloan Digital Sky Survey had its spectrum, confirming it as a massive blue star near the end of its life. Astronomers expected that someday it would explode, leaving behind a neutron star or black hole. Instead, in Webb's latest observations, it was missing. There was no supernova remnant, no glowing nebula, no expanding shell of gas. Only a compact infrared source remained, faint but unmistakable, feeding on material nearby. The conclusion was unavoidable. The star had collapsed directly into a black hole, without a supernova. When the news first broke inside the astronomy community, skepticism ran deep. Could an error in calibration have erased the star's light? Could dust obscuration have hidden the explosion? Could a background galaxy be masquerading as a black hole? Teams across the world dug into archives. Observatories from Chile's Very Large Telescope VLT to Hawaii's Keck searched for earlier glimpses. The Chandra X-ray Observatory revealed a faint X-ray glow where none had existed before. Evidence of a compact object devouring matter. The Very Large Array VLA in New Mexico added radio whispers, consistent with a black hole accretion disk. Piece by piece, the puzzle assembled itself. The star had been real. Its disappearance was real. And the compact object left behind was devouring material in silence, its presence betrayed only to the most sensitive instruments. It was not the first time a star had seemingly vanished without a supernova. Astronomers recalled the case of NGC 6946 BH1, a red supergiant 20 million light-years away that had brightened slightly, then simply faded, leaving no explosion. But that event had been debated for years, its evidence thin. The Infinity Galaxy, however, was different. Here, the tools of modern astrophysics converged. Infrared, X-ray, and radio, all pointing to the same chilling truth. To appreciate the magnitude of this discovery, one must remember how stars have always been observed to die. The supernova of 1987A in the Large Magellanic Cloud was visible to the naked eye, the brightest supernova in centuries. It became a laboratory for stellar death, its neutrino burst detected by underground detectors, its light curve studied for decades. That event had set the standard. When massive stars die, they announce it loudly, in fireworks that leave behind luminous remnants. Astronomers had built models of galaxy evolution on this assumption. Supernovae were counted not just as deaths, but as engines of chemical enrichment and feedback. Galaxies shone with their echoes. The idea that stars could die invisibly undermined not just a single theory, but an entire foundation of astrophysics. The Infinity Galaxy's silent collapse therefore represented more than a curiosity. It was a fracture line in the story of cosmic evolution. The turning point came in July 2025, when Peter van Dokkum, Yale, and Gabriel Brammer, Copenhagen, presented their analysis of Webb-S Infinity Galaxy data. They showed archival Hubble images side by side with JWST's infrared frames. Where once a star had burned, there was now only void. The room fell silent. Not because astronomers had never imagined silent collapse. Theoretical papers had proposed it for decades, but because no one had ever seen such a clear case, confirmed across multiple wavelengths, embedded in the chaos of a colliding galaxy. It was as though the universe had performed a magic trick, erasing a star before humanity's very eyes. A performer who had taken the stage for billions of years, only to vanish without a bow. The shockwaves rippled quickly. Papers flooded, arXiv, debates erupted at conferences. Was this truly a direct collapse black hole? The long-theorized heavy seed that might explain the monstrous black holes of the early universe? Or was it a rare form of failed supernova? Or something stranger still, involving physics beyond the standard model? Whatever the answer, the discovery phase was complete. Humanity had not only found a galaxy shaped like infinity, it had found within it a star that died in silence, forcing science to confront questions it had avoided for generations. The Infinity Galaxy became more than an object of curiosity. It became a mirror. In its figure-eight shape, humans saw eternity. In its silent star, they saw fragility. The discovery was not just about astrophysics. It was about humility, the recognition that the universe does not always shout its truths. Sometimes, it whispers them into the abyss, leaving us to listen carefully, with instruments stretched across the cosmos, straining to catch the faintest traces of what has vanished. And so the stage was set for the next act. The shock. If stars could die without spectacle, what else had humanity misunderstood about the cosmos? The universe has always staged its endings in fire. For centuries, humanity believed that when a massive star reached the end of its life, it would die with grandeur. A titanic supernova, an explosion bright enough to be seen across galaxies, scattering its ashes to become the raw ingredients of planets, oceans, and life. Death in the cosmos, like life, was supposed to be loud. But in the summer of 2025, astronomers faced a silence they could not ignore. Every astrophysics textbook had described it with certainty. A massive star burns through hydrogen, then helium, climbing the ladder of fusion until iron forms in its core. Iron, stubborn and unyielding, cannot release energy through fusion. The delicate balance between outward pressure and inward gravity collapses. The star's core implodes, while its outer layers rebound in a violent explosion. For days or weeks, its brilliance rivals the light of billions of suns. This was the script repeated across the night sky. The death of stars is fireworks. Humanity had even seen one with its own eyes. In 1987, a supernova flared in the Large Magellanic Cloud, visible to naked observers on Earth. Neutrinos raced through detectors deep underground, carrying the first whispers of collapse. The light followed, dazzling telescopes for years. That event became the standard against which all stellar deaths were measured. So when the Infinity Galaxy offered the opposite, a death without spectacle, scientists recoiled in disbelief. At first, the data felt like an error. How could a star, recorded in surveys for decades, simply vanish without a trace? Where was the burst of neutrinos? Where was the expanding shell of gas? Where was the light curve, the rising and fading glow that marks the passing of giants? The silence was absolute. Webb's infrared eyes saw only faint warmth and dust. Chandra's X-ray observatory registered a compact but steady glow, too small and too faint to be an explosion's aftermath. IceCube, buried in Antarctica's ice, reported no neutrino surge. LIGO and Virgo, the twin ears of gravitational waves, detected nothing. It was not just a mystery, it was a violation of expectation. The announcement landed like a tremor at international conferences. Peter Van Dockum and Gabriel Brammer presented side-by-side images. Hubble's archival view, where a bright star shone between colliding rings, and Webb's present-day frame, where it had vanished. The room held its breath. For many, this was the first time they had seen evidence of a direct collapse black hole. A star folding into darkness without an explosion. Some scientists leaned forward with awe. Others shook their heads, whispering doubts. Was it dust obscuration? Was the star merely hiding, its light veiled by turbulent gas? Could a background object be mimicking the signature? But as the data accumulated, resistance weakened. Too many independent instruments told the same story. The star was gone, and in its place was a black hole feeding quietly on its surroundings. The shock was not only observational, it was emotional. Astronomers are trained to accept surprises, but this felt like betrayal. The universe had broken its own promises. Physics itself seemed complicit in the deception. Einstein's theory of relativity predicted that if a star's core crossed a threshold of mass, collapse into a singularity was inevitable. Yet even those equations assumed an outward release of energy. The universe should have flared before it folded. Hawking had warned of the paradoxes that black holes impose. He spoke of the information paradox, the possibility that history itself could be erased by horizons. But even he may not have imagined such quiet cruelty. A death with no funeral, a transformation with no witness. The Infinity Galaxy made those warnings real. If stars could die invisibly, then the very record of their existence might be swallowed. Light, memory, evidence, gone in silence. Theories existed, long debated, but seldom believed. Astronomers had occasionally suspected failed supernova. In these rare cases, the collapsing core consumes the outer layers, rather than blasting them outward. A weak flash, a dimming, and then nothing. In 2009, a star in galaxy NGC 6946 had faded mysteriously, leaving a suspected black hole. But the evidence was incomplete. The Infinity Galaxy's event was sharper, louder, in its silence. There was no ambiguity. The collapse had happened, and no explosion marked it. The implication was staggering. If one star could die this way, perhaps many had. Entire populations of black holes might have been born invisibly, their existence betrayed only when they began to feed. Humanity's census of black holes, already estimated in the hundreds of millions, could be a fraction of reality. In interviews, scientists reached for metaphors. "It is a death without a eulogy," one said. "Like watching a candle snuffed out by an invisible hand," another whispered. "The universe is darker than we thought." The words carried weight because they reflected not just science, but emotion. Astronomers dedicate lifetimes to tracing the light of stars. To see one vanish without farewell was personal. the Infinity Galaxy became a ghost story, not told in myths, but in data tables and spectral lines. As the news spread, the public seized on the story. Headlines declared, "The star that died without a sound." Documentaries illustrated it as a giant sun crumbling into nothingness. For many, it became a metaphor for mortality itself. Social media filled with art, paintings of stars fading, poems about silence, animations of galaxies haunted by ghosts. What had begun as a technical discovery became a cultural mirror. Humanity, staring into the universe, found its own fragility reflected back. The implications were profound. If silent collapses were real, galaxy evolution itself had to be reconsidered. Supernova had long been thought to seed the cosmos with heavy elements. But if stars died without explosion, what happened to those elements? Were they locked forever within horizons, never to enrich space? Or were they released more subtly, in ways not yet understood? Models of black hole growth were also shaken. The early universe hosts black holes, billions of solar masses wide, seen less than a billion years after the Big Bang. Their existence has always puzzled cosmologists. How could they grow so quickly? The Infinity Galaxy offered an answer. Perhaps they were born large, in silent collapses that skipped the supernova stage. If so, the universe's first black holes may have been far more common, and far more massive, than anyone believed. The shock deepened into something primal. If stars could vanish silently in distant galaxies, could the same occur nearer to home? Would we one night look for a star in our own Milky Way and find it gone, erased without spectacle? The thought haunted astronomers and laypeople alike. The Infinity Galaxy had not only rewritten science, it had unsettled humanity's sense of stability. Stars, once thought eternal in their lifespans, now seemed fragile. Their deaths could pass unnoticed, leaving us to wonder what else might vanish unseen. In the end, the shock of infinity was not just in its data, but in its implications. Science thrives on predictability, on patterns that repeat. The death of stars had seemed one of the universe's most reliable performances. Now that reliability was gone, the silence of the Infinity Galaxy was a revelation, but also a warning. The universe is stranger than our textbooks, and its truths may not always arrive with light. The scientific community reeled. But one thing became clear. This was no longer a hypothesis. The Infinity Galaxy had shown them a death without a sound. It was shocking, terrifying, and humbling. The stage was now set for the next step: investigation. If stars could vanish like this, astronomers would need every tool, every detector, every archive, to pursue the truth hidden in the silence. The cosmos rarely offers answers without riddles. The disappearance of a star in the Infinity Galaxy had shattered expectations. Now came the harder task. Not to marvel at its silence, but to prove it. The deeper investigation began. James Webb's near-infrared camera returned to the Infinity Galaxy again and again, like a witness re-examining the scene of a crime. Each exposure mapped the faintest embers of dust. Each spectrum analyzed the hidden light. Astronomers hunted for clues of an explosion. The glowing remnants of heavy elements, the spectral fingerprints of oxygen, silicon, calcium, nothing appeared. Instead, NIRCam revealed a faint but persistent infrared glow, emanating not from a nebula, but from a compact region barely larger than our solar system. It flickered subtly, consistent with matter accreting onto a dense core. Where light had failed, gravity had continued its work. The mid-infrared instrument myriaded more depth. It saw dust warmed unevenly, suggesting energy sources buried in the dark. Yet the scale was wrong for a supernova. A true explosion would have lit the galaxy like a beacon. This was something quieter. Heat without fireworks. If Webb revealed the present, archives revealed the past. Astronomers dug into decades of imagery, from Hubble's ultraviolet surveys to ground-based optical scans. The missing star had been catalogued faintly by the Sloan Digital Sky Survey. It had appeared stable, massive, and bright. In Hubble's advanced camera for surveys, it glowed steadily, its color betraying an aging giant nearing the end of its life. Now, in Webb's images, the coordinates showed only absence. Like a missing line in a symphony, its silence was deafening. To ensure it was no mistake, Astronomers compared star charts, pixel by pixel. Automated software confirmed what human eyes had already seen. A beacon erased from the heavens. In Massachusetts, the Chandra X-ray Observatory team combed through their data. At first glance, the Infinity Galaxy was a cacophony of hot gas, shocks from colliding galaxies, and the brilliance of active galactic nuclei. But in the region where the star had once lived, a faint X-ray point source emerged. It was small, steady, and hungry. Its energy output was far less than that of a supernova remnant, but unmistakably compact. Only a black hole feeding on nearby matter could explain it. The absence of explosion, paired with the quiet whisper of accretion, made the case clearer. The star had collapsed inward, birthing a black hole in silence. If light and X-rays gave ambiguous answers, neutrinos and gravitational waves promised clarity. At the South Pole, IceCube scanned its records for bursts of neutrinos in the direction of the Infinity Galaxy. In 1987, neutrinos from SN 1987A had reached Earth hours before light, carrying the news of collapse. But in 2025, IceCube saw nothing. No spike, no flood. The silence spoke louder than data. This collapse had been different. Gravitational wave detectors across Earth LIGO in the US, Virgo in Italy, Kagra in Japan scoured their minds. No tremors appeared. No ripple of space-time announced the star's fall. It was as if the universe itself had hidden the death from every messenger particle it could muster. When the sky offers silence, theory must speak. Teams of astrophysicists turned to supercomputers. They built simulations of massive stars collapsing under their own weight. In one model, photons became trapped in the collapsing core, bouncing endlessly until swallowed. Another showed outer layers falling back inward, smothering any outward blast. Some runs suggested that neutrinos themselves could escape silently, carrying away energy, but leaving no detectable trace on Earth across such distance. The simulations converged on one truth. Under extreme conditions, stars could indeed collapse without explosion. What Webb had seen was not impossible, just rare and terrifying. The Infinity Galaxy forced astronomers to ask a dangerous question. Had they missed such deaths before? AI algorithms were trained to search sky surveys, not for bright flares but for absences. Petabytes of data from Pan-STARRS, Keck, and Hubble were reanalyzed. To their astonishment, the AI flagged dozens of candidates. Stars, once catalogued, later missing, with no record of an intervening supernova. Some were errors, some were obscured by dust, but a few looked disturbingly similar to the Infinity case. The silence might not be unique, it might be common. As evidence mounted, the investigation grew global. Telescopes in Chile, Hawaii, Spain, and South Africa turned to the Infinity Galaxy. Radio observatories, like the VLA and ALMA, detected faint emissions consistent with matter spiraling inward. Each observation was a thread. Together, they wove a tapestry of absence. No explosion, no light, only a quiet black hole where once a star had burned. The scientific community, fractured at first, began to coalesce. The Infinity Galaxy was no illusion. It was real, and it demanded explanation. Yet the deeper astronomers dug, the stranger the mystery became. Why had no neutrinos been seen? Why had no gravitational waves stirred? Was the collapse too symmetrical, too perfect to produce detectable signals? Or had something more exotic occurred? An interaction with dark matter, an energy leak into dimensions beyond our own. The silence was not just an observational absence, it became a philosophical presence, a reminder that the universe is under no obligation to explain itself. The deeper investigation brought clarity and confusion in equal measure. The Infinity Galaxy had shown them a silent death, and every instrument confirmed it. Yet in confirming, it deepened the mystery. What they had once thought impossible was now undeniable. But the question that loomed larger was terrifying. If stars can die in silence, how many have already done so, unseen and uncounted, across the history of the cosmos? The silence of one star had become the voice of a hidden universe. The universe had delivered its shock. A star in the Infinity Galaxy had vanished without a sound. But as astronomers pressed deeper into the data, the story grew stranger, darker, and more unsettling than anyone had imagined. The investigation, once about one missing star, began to unravel a larger truth. That silence might not be an exception, but a rule. It started with flickers. In the months after Webb's discovery, astronomers pointed instruments toward neighboring stars within the colliding rings of the Infinity Galaxy. They expected stability. Instead, they saw irregular brightness shifts, subtle dips and rises, as though gravitational tides were tugging invisibly. Some dismissed these as dust clouds shifting across sightlines. Others whispered that they might be echoes of collapse. Neighboring stars, disturbed by an unseen mass forming nearby. Gas clouds within the galaxy added to the mystery. Webb's mirror recorded turbulence out of proportion to known stellar winds. Dust shimmered strangely, as though stirred by a force without light. Nothing fit neatly into the models. The Infinity Galaxy seemed to host more than one enigma. As the anomalies multiplied, so did the debates. At conferences in Geneva, Pasadena, and Tokyo, the scientific community fractured into camps. One group declared victory. The Infinity Galaxy had delivered proof of direct collapse black holes. The heavy seeds long theorized to explain the monstrous black holes seen in the infant universe. For them, the silence was not a mystery, but a triumph, confirming decades of speculation. Another group resisted. They argued that what Webb had seen was a trick, a star hidden behind dust, a background galaxy misinterpreted, or a transient event misclassified. They pointed to the absence of neutrinos, the absence of gravitational waves, as evidence against collapse. But even among skeptics, unease grew. The more the data was scrutinized, the harder it became to escape the conclusion that something had indeed vanished. And if so, the implications reached far beyond one galaxy. The greatest fear was not that the Infinity Galaxy hosted a silent collapse, but that such collapses were common. AI systems, unleashed on Sky Survey archives, began flagging similar disappearances. Stars once catalogued, later missing, with no supernova recorded. Some were explained by errors or dust, but others remained stubbornly unaccounted for. If these silent deaths were real, then the census of black holes across the universe was wrong by orders of magnitude. There could be not millions, but billions more, born invisibly, shaping galaxies from the shadows. The silence of one star began to echo across cosmic history. How many had died unseen? How many had been born in darkness? As the debates raged, the story escaped the halls of science. Media seized on the drama. Headlines declared, "The ghost stars of the universe and silent black holes haunt the cosmos." Artists painted the Infinity Galaxy as a cosmic graveyard. Documentaries rendered stars vanishing in eerie silence. Social networks buzzed with metaphors. Marriages ending like stars without a supernova. Civilizations collapsing without sound. The discovery transcended science. It became cultural poetry. And with poetry came fear. If stars could vanish silently, what else could? Our own sun, though less massive, holds similar secrets. Could silence descend closer to home? In lecture halls and late-night discussions, the implications turned philosophical. For millennia, humanity had looked at the stars as symbols of permanence. Stars were anchors, constants, steady lights in the sky. Now, that constancy was in doubt. Stars, like humans, could die quietly, unannounced, their legacies swallowed by horizons. Some philosophers drew parallels to civilizations lost without record, cultures erased without witness. The universe, they argued, was teaching a humbling lesson. Not all endings announce themselves. The silence became not just a scientific puzzle, but a metaphor for existence. Then came new observations that pushed the mystery even further. Webb detected faint ripples of energy in dust clouds far from the collapse site, as though waves had traveled outward, unseen. Chandra's X-ray whisper grew slightly stronger, suggesting the black hole was feeding more aggressively. The Very Large Array picked up faint radio emissions, consistent with jets streaming from a newborn black hole. Yet none of this explained the silence of the collapse itself. If matter was falling inward now, why had it left no initial blaze? Some suggested the collapse had been too symmetrical, producing no gravitational waves. Others theorized that energy had escaped in forms humanity could not yet detect. Into dark matter, or even into dimensions beyond space-time. Each new clue added to the escalation. The Infinity Galaxy was no longer a single puzzle. It was a doorway into questions that threatened the foundations of astrophysics. The escalation forced cosmologists to reconsider the timeline of the early universe. Supermassive black holes had been found lurking less than 1 billion years after the Big Bang, too massive to explain with ordinary growth. The Infinity Galaxy suggested that heavy seeds could form silently, accelerating growth in ways never accounted for. This meant that the architecture of the cosmos itself, the clustering of galaxies, the formation of structure, the distribution of matter, might have been shaped not by explosions, but by silence. The dread deepened. The greatest architects of the universe might not be visible forces, but invisible collapses, sculpting reality in ways humanity had never imagined. For scientists working on the Infinity Project, the escalation was personal. They had set out to map galaxies, to catalog starlight. Instead, they found themselves chronicling absence. Some admitted to sleepless nights. Others confessed to fear. To dedicate a life to light, only to discover that the most important transformations happen without it, was disorienting. One astronomer, interviewed quietly, said, "We used to think the universe was written in light. Now I wonder if most of it is written in silence." The investigation had revealed more than an anomaly. It had revealed a new reality. The Infinity Galaxy was not simply a curiosity. It was a challenge, a fracture, a wound in the narrative of cosmic evolution. The shock had given way to escalation. The mystery had deepened. The silence was no longer absence. It was presence. Vast, unsettling, and unavoidable. The universe, it seemed, had chosen silence as one of its dominant languages, and humanity had only just begun to learn how to listen. The Infinity Galaxy had given humanity a silence too profound to ignore. A star had died without a flare, leaving only absence where brilliance once burned. But science cannot survive on silence alone. It demands explanation, even when explanations strain at the edges of imagination. From this silence, theories emerged, some grounded, some speculative, all haunted by the same question. How can a star collapse into a black hole without a sound? The first and most powerful theory was the direct collapse model. For decades, astrophysicists had struggled to explain the existence of supermassive black holes in the early universe. Less than 1 billion years after the Big Bang, telescopes had found black holes billions of times the Sun's mass. Ordinary growth from stellar remnants could not explain such monsters. The direct collapse theory suggested a solution. Instead of small seeds growing slowly, some stars or gas clouds skipped the fireworks and collapsed whole, forming heavy seeds, black holes, tens or hundreds of thousands of solar masses at birth. The Infinity Galaxy seemed to confirm this. Its missing star did not explode. It folded directly inward, birthing a black hole, silently, as though gravity itself refused to waste energy on spectacle. If this model is correct, then silent collapses may not be rare accidents. They may be the foundation stones of cosmic architecture, the hidden engines that built galaxies. Another explanation looked less exotic, but equally chilling. Failed supernova. In this scenario, a star begins to collapse, as expected. Its core implodes, neutrinos flood outward, and its outer layers attempt to rebound. But gravity wins. Instead of blasting free, the layers fall back inward, smothering the explosion. The result: no bright flare, no expanding remnant, only collapse. The energy vanishes into the event horizon, as though swallowed whole. Astronomers had long suspected such failures might occur in very massive stars, but evidence was elusive. The Infinity Galaxy provided the clearest case yet. The consequence is unsettling. If failed supernovae are common, then the cosmic record is incomplete. Humanity has celebrated the deaths of stars seen across the sky, but for every supernova witnessed, dozens more may have died invisibly, their legacies erased from view. Some theorists focused on the physics of collapse itself. In a supernova, radiation drives the explosion. But what if the collapsing core becomes so dense, so quickly, that even photons cannot escape? Models of photon trapping suggest that as matter falls inward, light is scattered so many times that it never breaks free. Energy, instead of radiating outward, is dragged down into the forming black hole. In this picture, the star does release energy, but only into its own grave. To observers across the universe, the collapse appears silent. Neutrinos are often the heralds of stellar death. In SN 1987A, a flood of neutrinos reached Earth before the light, announcing the collapse. But in the Infinity Galaxy, detectors like IceCube recorded nothing. One possibility is that neutrinos still carried away the energy, but at such distance, to 8 billion light-years, the signal was too faint to detect. Another possibility is stranger. The collapse may have channeled energy into exotic neutrino flavors that pass unnoticed by Earth's instruments. If so, then humanity may be blind to one of the universe's most common languages. Beyond known physics lies speculation. Could dark matter or dark energy have played a role in the Infinity Galaxy's silent collapse? Dark matter, unseen yet dominant, weaves the scaffolding of galaxies. Some theorists wonder if stars collapsing in dense dark matter halos might lose their energy to interactions we cannot detect. The collapse would still occur, but its light would bleed into a hidden sea. Others turn to dark energy, the mysterious force driving cosmic expansion. Could the collapse of massive stars coupled with dark energy, bleeding their death throes into the accelerating fabric of space? If true, the Infinity Galaxy might not simply be a grave, it could be a conduit, where visible matter vanishes into the invisible forces that shape the cosmos. The silence of infinity resurrected old philosophical wounds. Stephen Hawking's information paradox had long haunted physics. Does information about matter swallowed by black holes disappear forever, violating the laws of quantum mechanics? In the Infinity Galaxy, the question sharpened. A star had not only died, but erased its own death. No light, no supernova remnant, no neutrino burst. If even the evidence of death could vanish, then what else might be lost to horizons? Some physicists speculate that the information is preserved in subtle fluctuations of Hawking radiation, imperceptible across cosmic timescales. Others argue for more radical answers, that our universe itself may be a black hole, its boundaries defined by horizons we cannot cross. In this frame, the Infinity Galaxy is not anomaly, but reflection, a microcosm of reality itself. A more speculative theory dares to stretch imagination further. What if the collapse was not only silent, but transformative? Some cosmologists suggest that every black hole may seed a new universe beyond its horizon. In this view, when the star in the Infinity Galaxy collapsed, it did not end. It began anew, birthing a cosmos invisible to us, connected only by the silence of its parent's death. If true, then our universe may itself be the child of another star's collapse, a silent death in some grander multiverse. Infinity, then, is not metaphor, but literal truth, a chain of creation through silent endings. One of the strangest features of the Infinity Collapse was the absence of gravitational waves. LIGO, Virgo, and Cagra recorded nothing. Theories suggest that if a collapse is perfectly symmetrical, it emits no ripples in spacetime. This perfection would be rare, almost unnatural. But the Infinity event seemed to achieve it. Did the universe hide its violence behind symmetry? Or did the collapse channel its energy elsewhere, beyond our dimensions? Either answer leaves humanity humbled. Some voices, less constrained, speculate freely. What if the collapse connected to wormholes, opening bridges between regions of spacetime? What if stars could tunnel through quantum barriers, vanishing into parallel realms? What if silent collapses are cosmic resets, where matter reconfigures into forms beyond our comprehension? Most scientists remain cautious, grounding their models in data. Yet even speculation carries value, for it widens the horizon of imagination. Beyond physics, the Infinity Galaxy forced a philosophical confrontation. Humanity has always measured reality through light. Telescopes' eyes, cameras, all rely on photons. To be unseen is often equated with not existing. But the Infinity Collapse revealed that the universe does not conform to this bias. The most profound transformations may be invisible, hidden from the instruments of light. Reality does not need to be witnessed to be real. For philosophers, the message is humbling. What else occurs beyond perception? What truths exist in silence? The cosmos is not obliged to reveal itself. We must build ever finer tools, and even then, much will remain veiled. In the end, the theories circle back to two voices: Einstein and Hawking. Einstein's relativity foretold collapse, but could not capture its silence. His equations predicted horizons, but not the psychology of absence. Hawking, decades later, gave black holes their paradox. He argued that horizons might evaporate, whispering secrets back into the universe as Hawking radiation. Yet infinity shows us that for now, the whispers are beyond hearing. Together, their legacies frame the mystery. Physics can predict collapse. Philosophy must interpret silence. The infinity galaxy has become a crucible of theory. From direct collapse models to multiverse speculations, from failed supernova to quantum paradoxes, it has forced science into uncharted territory. Each theory is provisional, each speculation a lantern held against the dark. None are final. The star's silence remains, resisting explanation, mocking certainty. But this is the essence of science, not answers, but pursuit. The infinity galaxy has not ended the story of black holes. It has only begun a new chapter, written not in light, but in silence. The infinity galaxy had whispered a riddle. A star had died without spectacle, folding silently into a black hole. Science could not accept silence without pursuit. To chase the absence, humanity turned to its arsenal of instruments: eyes that see beyond sight, ears that hear space-time itself, detectors that listen for the faintest particles in the void. If the universe had chosen silence, then humanity would invent new ways to hear it. At the heart of the investigation stood the James Webb Space Telescope, its gold mirrors unfurled in the cold of L2, staring into the infinity galaxy. NIRCam, Webb's near-infrared eye, had been the first to see the absence. A star missing, a void glowing faintly with the warmth of dust. Now it returned again and again, building light curves of nothingness. Each spectrum, each pixel, was compared to Hubble's archives. The differences mapped the star's erasure like chalk lines around a vanished figure. MIRI, Webb's mid-infrared instrument, traced the dust stirred in the collapse's aftermath. The glow was faint, uneven, and wrong for a supernova. It was quiet heat, the signature of matter sinking inward rather than exploding outward. Webb became not just a telescope, but a detective, interrogating silence with wavelengths invisible to human eyes. But Webb cannot watch the entire sky. For every infinity galaxy revealed, countless others remain unexamined. That task falls to the Nancy Grace Roman Space Telescope, scheduled to launch before the decade ends. Roman's wide-field instrument will scan vast stretches of the sky in infrared, with sensitivity rivaling Hubble and breadth approaching Webb's. Where Webb peers like a magnifying glass, Roman will sweep like a lantern across the heavens. Astronomers plan to use Roman not to look for light, but for its absence. Automated algorithms will compare Roman's catalogs to decades of Hubble, Sloan, and Pan-STARRS data. Stars that have vanished silently will be flagged. In this way, Roman will act as a census taker of ghost stars, building a library of disappearances. For the first time, humanity may know how common silent collapses truly are. While Webb and Roman watch, an infrared, Chandra X-ray observatory listens for higher energy whispers. In the infinity galaxy, it recorded a faint point source, the afterglow of matter spiraling inward. But Chandra's mission is aging, its detectors limited. To continue, the European Space Agency prepares Athena Advanced Telescope for high-energy astrophysics. When it launches in the mid-2030s, Athena will scan the X-ray sky with unprecedented precision. If silent collapses leave behind accreting black holes, Athena will see them more clearly than ever. It will map the shadows of vanished stars. Light can lie, but neutrinos rarely do. At the South Pole, beneath a kilometer of ice, the IceCube Neutrino Observatory waits for ghostly particles. In 1987, neutrinos carried the first message of a star's death. But in 2025, infinity sent none. Still, IceCube listens. Its sensors, spread across cubic kilometers of Antarctic ice, detect flashes of blue Cherenkov light when neutrinos strike. Each detection is a whisper from the core of the universe. So far, silence. But with upgrades, IceCube will grow sharper, listening for bursts too faint to catch before. If silent collapses release energy only in rare neutrino flavors, perhaps IceCube will one day hear them. On Earth, gravitational wave observatories, LIGO in the United States, Virgo in Italy, Kagra in Japan, strain to hear ripples in spacetime. Black hole mergers have sung through their detectors, but the infinity collapse was silent. Why? Perhaps the collapse was too symmetrical. Perhaps the waves were too faint, lost in cosmic distance. The future lies in LISA, the Laser Interferometer Space Antenna, a trio of spacecraft forming a triangle millions of kilometers across. Launching in the 2030s, LISA will listen to the deep bass of the universe, detecting gravitational murmurs Earth cannot hear. If silent collapses sing at frequencies too low for LIGO, LISA may catch their notes. Even as instruments reach forward, algorithms reach backward. Artificial intelligence now combs decades of sky surveys. Sloan, Hubble, Keck, Pan-STARRS, searching not for flashes, but for vanishings. Each candidate is checked. Was it obscured by dust? Was it a variable star? Was it human error? Slowly, a pattern emerges. Some stars have indeed disappeared quietly, without recorded explosion. AI becomes the archivist of absence, building humanity's first tentative list of ghost stars. The infinity galaxy may be one of many. No instrument stands alone. Webb's infrared, Chandra's X-rays, IceCubes, neutrinos, LIGOs, spacetime ripples, Roman's surveys, Athena's promise, LISAS, dream, all are threads in a single net humanity casts against the silence. International collaborations coordinate targets, share data, refine theories. Astronomers across continents become detectives in a case too large for any one nation. The infinity galaxy, billions of light years away, unites Earth in common pursuit. There is poetry in the tools themselves. Telescopes are human eyes extended into the cosmos. Neutrino detectors are human ears pressed against the void. Gravitational wave observatories are fingers feeling the fabric of spacetime. AI is the mind, memory stretched across decades. Together, they form a body, a planetary organism straining to perceive what silence conceals. The infinity galaxy tests not only physics, but the limits of human perception itself. The deeper the investigation reached, the clearer one truth became. Silence is not absence. It is information encoded in forms. Humanity is only beginning to hear. The infinity galaxy challenged telescopes, detectors, and minds to evolve. In its quiet death, a star forced humanity to invent new ways of listening. Science continues. Each night, Webb peers into the abyss. Each day, algorithms trawl the archives. Each decade, new instruments rise. All are united by the same pursuit: to catch the universe in the act of silent transformation. The stage is set for reflection. If the cosmos builds and destroys itself in silence, what does that mean for humanity, for meaning, for existence itself? The answer lies not in instruments, but in philosophy, and in the closing whispers of the story. There are deaths that roar across the cosmos, and there are deaths that pass in silence. For centuries, humanity had known only the first, the bright, explosive endings of stars whose violence seeds the universe with life. But in the infinity galaxy, a different truth was revealed. A star can vanish without warning, without fireworks, without farewell. This silence is more than a scientific puzzle. It is a philosophical mirror. Human beings have always trusted the stars. They burn steadily across the heavens, marking seasons, guiding travelers, anchoring myths. Their constancy has made them symbols of permanence in a fleeting world. Yet the infinity galaxy whispers a harsher truth. Even the brightest can disappear quietly. Their stories erased without spectacle. It reminds us that certainty itself is fragile. What we believe to be eternal may dissolve without notice. What we trust to remain may be gone when next we look. To the astronomer, the star's silence is unsettling. To the philosopher, it is profound. For silence is not absence, it is potential. When the star collapsed into a black hole, it did not end, it transformed. In its silence, a new engine of gravity was born, one that will shape the galaxy's future. Around it, stars may be pulled, orbits bent, matter consumed. In time, it may anchor new structures, seed new cycles. So too in life. Endings without spectacle can still give birth to beginnings unseen. The silence of infinity is not void, but creation hidden from view. The infinity galaxy reminds us that the universe does not perform for our eyes. It does not owe us brilliance or clarity. Stars do not explode for our cameras. Black holes do not roar for our instruments. Reality unfolds on its own terms, indifferent to witness. And yet, in that indifference lies a strange beauty. For it is precisely because the universe is not designed for us that its mysteries are authentic. Its silence is honest. Its secrets are real. Einstein gave us the mathematics of collapse. Hawking gave us the paradox of horizons, but neither equations nor paradoxes prepared us for the psychological weight of silence. When the star died unseen, it reminded us that knowledge itself is incomplete, that there will always be truths beyond reach, horizons beyond crossing. But it also affirmed why science matters: to approach the silence with humility, to extend perception even when certainty is impossible. The infinity galaxy becomes a dialogue between science and philosophy. The physicist asks how. The philosopher asks why. The silence answers both with mystery. There is, too, a human resonance. Civilizations rise and fall. Lives begin and end. Some make noise. Others pass quietly, unnoticed. The infinity galaxy teaches that silence does not mean insignificance. A star that died without spectacle still shaped its cosmos. A life that ends without fame still touches eternity in ways unseen. Perhaps the greatest humility we can learn is this: meaning does not require witness. The universe is filled with silent transformations. We are part of them. Science responds to silence with tools: Webb, Chandra, Ice Cube, Lisa. But philosophy suggests another response: listening, not only with instruments, but with imagination, reflection, humility. The infinity galaxy teaches us to hear absence, to treat silence itself as data. It tells us that what is missing is as important as what is seen. In this way, silence becomes not emptiness, but language. The cosmos speaking in whispers instead of shouts. As the infinity galaxy drifts across the night sky, its rings glowing faintly 8 billion light-years away, we know that one of its stars has vanished. We know that its death made no sound, no light. We know that silence itself can be the sign of transformation, and in that knowledge lies a new way of seeing. The universe is not built only of explosions and brilliance. It is also built of vanishings, of quiet transformations, of secrets kept in shadows. To live in such a universe is to accept that we will never see everything, never hear every song. But perhaps that is the point. Infinity is not meant to be grasped, only glimpsed. Silence is not meant to be filled, only honored. The star in the infinity galaxy is gone. Its light will never return. But its silence will echo through science, philosophy, and imagination for centuries to come. And in that echo, humanity will continue its journey, building instruments, writing theories, crafting stories, not to conquer the silence, but to walk within it. Because in the end, the universe may not speak in fireworks at all. It may speak in silences vast enough to humble us, deep enough to shape us, and eternal enough to remind us that we, too, are fleeting sparks within its infinite, quiet night.